Hey folks, VM Explorer here. Good day to you. I hope things are going well for you. In today's 10 gigabit NAS home lab, we're doing part 8, which is interconnecting those MikroTik switches and then doing some speed testing. Right. So just a quick note, the purpose of this session is to show how to interconnect two MikroTik switches and ensure their performance is optimal when compared to single switch. The two NAS devices in this session have different physical capabilities, and by no means is this a comparison of their performance. The results are merely data points to kind of help me gauge the performance through the switches and have I got the right settings and things set up properly. My recommendation or rule of thumb is users should always work with their vendor of choice to ensure best performance and optimization, and that's what I've done in this lab. Is I've had conversations with the different vendors to make sure I'm trying to set up things the best I can. All right, Matt, I'm going to interrupt you for just a minute there, so hold off. Hey folks, sorry to interrupt the video here. I just want to let you know that I recorded this part 8 a few months back, and during that time I was coming up with some anomalies with the LockerStor 10 as far as its performance, right? Its numbers weren't quite where I thought they should be. So I've worked with their engineers in depth, trying to resolve this issue. I tried different configurations, different setups. I had tried different switches. I tried a lot of different things, but all my results were coming back the same. I opened up a service request and worked with them directly, explained all my findings to them, kind of explain what's going on. And they're working with their engineers right now to kind of double confirm my findings and see if they have got a potential issue that they want to look into. So stay tuned as things progress and things, if I get a patch or whatever they're going to come back with, right? I'll do a follow-up video and repost some updated numbers. Now, on this video, just keep in mind, what we really want to get out of this is how to use iPerf3 and kind of test out your network for speed issues, right? Really forgetting about the storage performance and focusing on the network performance and how to go about doing that. That's what this video is really about. So without further delay, I'm going to get right back to the video, and here we go. All right, so before we get started, check out vmexplorer.com or the YouTube channel. Lots of other videos there. For this one, I'd say a prerequisite is to watch part 7 at least, the network testing with iPerf3 containers, because we're going to talk a lot about iPerf3, but we're not going to go in the details exactly of how to enable it. Additionally, this particular session is all PowerPoint. I know I'd rather do home lab stuff, and show you things, but the amount of data and the amount of things that I've had to collaborate and reconfigure over and over and over again to try to get things optimal was immense. It was a lot, and it would be very hard to try to show you all the settings back and forth, so I've put it into a presentation to be able to explain it to you better. If it isn't something that works out for you, by all means, leave me a comment below and say, hey, Matt, that didn't work out really well, right? Can you show us more things? And I'll make a quick NAS topic and we'll go from there. So do leave those comments. I read them and try to reply to them all. And let's get on with the agenda, all right? So today, we're just going to kind of cover an update to the home lab topology to make sure we understand how everything's interconnected, some of the MikroTik and device lag settings, and then we're going to go through several speed testing, whether it's the single switch results, testing Link Agg, the Crisscross Test I call it, or a summary and results to kind of wrap things up. All right, so here's the update to the home lab topology. So I've made a few changes. The initial settings were good for the home lab to kind of get things started. But now I'm starting to move more towards a production environment with my ESXi hosts, soon to be ESXi hosts interconnected into my storage. I've run out of ports. I can't connect all my ESXi hosts and all my NAS devices into one switch. If I could, that would be great, but I can't. Ran out of ports. So I have to interconnect two switches, and that's when I started coming up with the idea of, okay, how do I do that, right? So what I've done is I've got two switches, the 248 switch on top, the 240 switch on the bottom. Everything runs on a 76 network. There is a management network here not shown. That's a 74 network, right? And that allows me to remote in and control these different devices, adjust their settings. The Synology uses DAC cables, and so does the interconnects between the two switches. The other devices, such as the LockerStor 10 and the PCs, all run 10 G base T shielded twisted pair cables, right? So they're all rated for 10 gig. We should be good there. Again, the two NAS devices we've been talking about in the different parts, the LockerStor 10 and the Synology DS1621 Plus, all 2 by 10 gigabit. The PCs, which we kind of call PC ASUS and PC Synology. The only reason I do that is because the tools for ASUS are installed on here, and the tools for Synology are installed on here, and that's how I've been making the videos on the two different boxes, is using the tools there. So I just kind of call them that. And again, 3 ESXi hosts not connected at this time. That'll be later parts where we interconnect these ESXi hosts into these devices and make sure they're optimal as they can be. All right, so let's go through the MikroTik and device lag settings. So I started out by going to the MikroTik website looking for documentation on how to do this. But I couldn't find anything around how to set this up. How do I interconnect to your switches? What's the best practice to do this? So I reached out to MikroTik. They responded with a couple solutions. First off is, by default, it doesn't work. You're just not going to be able to interconnect two links and have it work, right? So you have to make some adjustments, and we'll talk about these adjustments in a setting in a second, right? So for LACP, one side needs to be active mode and the other side passive. So this switch ports might be active, these might be passive, or all are active. So all 4 ports would be in active mode, or you could put it in a static lag and set up a group. So 3 different options, and that's where it gets complicated, right? Is, well, what option works the best? That's what I found out, was going through these settings and trying things out. I figured out which was optimal for my environment. And here's what I found out. By default, I had to change the settings, right? Like they said, everything is in passive by default, so it's not going to work. What I found, though, is that if I put one switch, like the 247 switch here, in active mode, and so I just go into the actual MikroTik GUI, right? Go to lag and SFP1, right? This one's passive. SFP8 is passive, but then on the other switch, 247, I set it to active and active like this. This was optimal. When I set it in active on the bottom and active on the top, I noticed that it wasn't as performant, right? It wasn't as fast. It was several gigabits slower. And I noticed that, and I was like, wow, that doesn't seem quite right. In some cases, on 10 gigabit connections, I was barely getting 2 gigabit. So once I put it in this mode, active, passive, right, everything started to flow much better. And that was the only change I had to do to the switch. The rest of the switch is pretty much default settings. And I put it in active passive mode for lag, and it worked out good. The other finding I had was whether it was the Synology or the LockerStor, I put those in active mode, and that helped when we installed their different logarithms, right? Whether it be their load balancing ones and their 802.3, etc. If I put it in active mode, it worked pretty well. In some cases, I had to put it in static mode, but we'll talk about that in a second. All right, should be familiar with iPerf 3, part 7 of this series covered that. For the LockerStor 10, I can run the Docker container, which I mentioned. They also have a fully enabled native app for iPerf 3 on their app store. You can run that too. The Synology 1621, I ran basically the Docker container and got those going. Again, go back to part 7, review that if you're not comfortable with these commands in iPerf. You might get lost here real soon when I start talking about the various commands. All right, speed testing. So the first thing I did was I wanted to interconnect everything into a single switch. So I got the LockerStor, I got the Synology, and I got the PCs, and I all put them on one switch. Why did I do this? Because I needed a baseline. I needed to understand what was my performance like with one switch. It should be absolutely the fastest. And if I connect 2 switches together and try and go across them, did it slow down or did it speed up? right? So that's why I needed a baseline, so I started with this. So using iPerf 3, I started doing tests. So between PC1 and PC2, I ran a test and got about 8 gigabit. Back to 2 and 1, same results. About 8 gigabit between the PCs is what I was averaging. When I did the PC directly to the LockerStor, I hit about 6 gigabit to it. But LockerStor back to the PC, we hit almost 10, which is interesting. Why would it be faster one way but not the other? For some reason it is. A lot of this data I still need time to kind of digest and figure out, but I tried different settings, checked it out. In some ways, some things are faster than the other. Now, when I pointed two PCs using iPerf to the LockerStor 10 with the ALB logarithm, I averaged about almost 6 gigabit, right, per PC, and then 11 gigabits here as well. Now, what I would do was I would run this test 3 times. So each number you see here is a result of an average. So I'd run the test 3 times. I'd get those 3 numbers, I'd add them up, and then I'd divide by 3 and would get this number. Now, on the ones where I had 2 PCs, right, what I would do is I would get all of those numbers, so 3 tests each, right, get those 2, their average, and then add them together to kind of get that aggregate of the total bandwidth that it's producing, right? Synology, same thing, PC to Synology, 8 gig, et cetera here, and then back and forth from the LockerStor. Now, why these are important is as we go through and we start interconnecting the switches, we're going to get results. And at the end, when I go through the summary, we'll kind of compare some of these results to the interconnected switches and see if it's about the same or where things changed. And that's why it was so difficult to kind of show all this physically, right? Interconnecting switches, different settings, etc., where things improve, where they didn't. The result of all these findings will kind of show us that at the end. All right, so starting testing link aggregation with the LockerStor 10. Basically what I've done is I've got the LockerStor 10 up and running. We're going to put it through single NIC testing with no logarithms. Then we're going to put in some link aggregation, and we'll do some different testing. So first the single NICs are up, then the 802.3 link aggregation, then their ALB link aggregation, and then the rest of their items are listed at the end. So here's how it works. We've got these 2 PCs up here running iPerf, and we've got our NAS devices running iPerf. The switches are interconnected, like I said, using that passive active mode. The PC's switch settings are in passive mode, and the NAS settings are in active. Though we're only using one NIC at this time, the other NIC doesn't have an IP address to address. So we go to the first PC and we use an MTU of 1500. Now I wanted to do this just to kind of get a baseline and comparison between 1500 and 9000, right? And then we say, okay, this PC connect to this NIC, okay, on port 5202. This PC with iPerf 3 use 5201. I basically get both commands up, I hit enter, and boom, they both go at the same time, and that's kind of how I do the testing. This is a similar pattern that we're going to see over and over as I go through, and it produces the results. All right, so the results for 1A with MTU of 1500, no link aggregation, single NIC testing. We saw about almost 7 gigabits here on a single, right? And when we had 2, we had a kind of an average of about 9 gigabit when I ran 2 at the same time to a single NIC, which is kind of what we'd expect. It's a single 10 gig NIC, right? We're not going to expect it to be like 12 or 15 or 16 gig. It's a single NIC, right? And then same on 1B. We saw about an average of 6 gigabit on a single PC, and then almost 10 gigabit when I ran 2 PCs against it. So let's enable link aggregation, right? So we're on the LockerStor 10. We enable its 802.3 AD. We didn't have to make any switch setting changes at this time. And I went ahead and ran both at the same time to get a result. So we'll do a single NIC first, right? Test it, see how it comes out, and then I'll run both. And we saw about 6 gigabit on a single and almost 12 gigabit when I ran 2 PCs against this logarithm. Then we shifted over to their ALB logarithm, okay, which is that adaptive load balancing. Same test again. No switch settings, no changes here. And we saw again 6 and about 12 on average. All right, now the rest of the LockerStor 10 logarithms here. So the one thing I like about the LockerStor 10 is the amount of link aggregation choices you have. Some of these are load balancing. Some of these are fault tolerant, like their active backup. You have an active path and a backup path. So if your active fails, your backup takes over. I wasn't really interested in the fault tolerant ones for this test. I really wanted the load balancing ones to kind of test out. Now they had a few others that we didn't show in the test above, the round robin test and the XOR test, right? Now this is where things changed a bit. I initially ran these tests against a active passive setup, where I set up the switches active passive. You've seen that over and over. However, when I ran active passive on round robin and XOR, it was bad. I mean, it was really bad. Their speeds was less than 2 gigabit. It was really slow. And this isn't a fault of the LockerStor 10. This is a fault of a bad switch configuration aligning to the logarithm. So I did a little bit of reading, and I noted they noted static wording was in there. It wasn't very detailed, but it was enough to kind of give me an idea. It's like, hey, maybe I need to adjust my settings, and that's what I did. I found out that this round robin here needed a static setup for LACP. Once I did that, boom, it shot right up and is in alignment with the other tests. As you can see here, we're getting almost 6 and almost 12, and again, almost 6 and almost 12. Their numbers shot up quite a bit. All right, so let's start with our Link Agg testing for the Synology. Again, similar tests, single NICs, 8023D, 8023AD, and their ALB, and then the rest of their load balancing items. All right, so single NIC test, same settings as before, right? Same things we covered, MTU of 1500, MTU of 9000 is the only real difference here. And we see about a little over 8 on 1500, right? And just about 9, a little over 9 with 2 NICs. Now, when we did 9000, the number dropped slightly, not much. Still about 8 gigabits on a single PC. And for some reason, with 9000, it exceeded the speed of a single NIC, giving us an average of 10.05 gigabits, which was an interesting finding using a single NIC. Right? Now we do 802.3, we enable that. Again, same settings, no changes here. We see an average for a single NIC connection getting about a little over 8 gigabit. And when I have 2 NICs going, we're seeing almost 16 gigabits out of those 2 NICs using this load balancing algorithm. Then we do the ALB. Again, no changes. ALB enabled on the Synology. We see about 8 and 16 again. All right, now the rest of the Synology Link Agg. So Synology, similar to the LockerStor 10, has different link aggregation modes. The ALB, which we went through, 8023AD, the balance XOR, right, and active standby, which is kind of that fault tolerance that we talked about. We tested the ALB and the 8023, but the XOR we tested here, and it came to the same conclusion. Once I figured out how the LockerStor 10 worked with needing static, right, I did the same test on the Synology. So initially active, passive, got bad results, switched it to static, which meant static lag groups, and the throughput shot up, right? So they have got some good choices. I think these are more common, right? They're not as verbose as the LockerStor, but I think that's okay. Most folks typically kind of rotate between these couple here. But if you want more options, then maybe the LockerStor is a better choice for you. 9. All right. The good old crisscross test. Now, one of the things I wanted to make sure is because we're running this kind of in an active connection here, passive here, what happened if I crisscross the data? Right now, we're kind of sending it all one direction towards those 2 NASs, right? But what if one was coming up and one was going down at the same time, back and forth? What would that look like, and would that affect the performance? The good news is no, it didn't affect the performance. The results were similar to what I had when the NASs were all down here. So the LockerStor 10, we saw about 6 gigabit connection. So we go from this PC here, When we go up into it, make a single NIC connection, you know, we see about 6 gigabits. When we do 2 PCs with their ALB enabled, right, we see about 12 gigabit connection up there, which was good. Okay. When we do the Synology test, very similar, 8 gigabit and 16 gigabit. And then also PC to PC was around 7 gigabit between the two. We also did a test this way. All right, so let's go over review some of the summary results here. I know this is an eye chart, a lot of data to go through. So these are results from the lags that we've set up in the middle here, and then the single switch results as well. Now, what I highlighted was really what I was most interested in, right? And not necessarily the numbers, but how close were the numbers from the results, from a single switch to a multi-switch. So we looked at kind of a single NIC MTU of 9,000, right? We see with the LockerStor 10, we're getting about 6 gigabit. And that's what I got also when I did the single test over here, was about 6 gigabit. That's a good sign. On the Synology, we hit about 8, and with the single switch, we hit about 8. This is good news. When we had the ALB logarithm enabled, right, we saw 6. Okay. We also saw 6 when I was doing it on the single switch with that logarithm enabled. We saw about 12, again about 12. These, as you can see, these numbers are very close, these highlighted numbers, whether it be the Synology or the LockerStor, whether it was on 2 switches interconnected or a single switch, the numbers were close. And that's what I was trying to figure out, is how can I get it close enough? How can I maintain a similar experience, whether I was on a single switch or a remote switch? Setting this up with the right settings, using that active-passive configuration between the 2 switches was what was key for me to doing these numbers. And then also making sure I understood when to adjust it from active-active for the NAS devices based on their logarithm. You know, these logarithms here pretty much all use the active-active, whereas the XOR and the round-robin needed static settings. So folks, that's what I had for you today. I appreciate you taking some time to listen in. Please leave your comments below. Maybe there's something I left out. Maybe there's a comparison that you have or some information you have that can help me out. I always appreciate it. Try to read all the comments and reply. Again, thank you so much, and I do hope you have a great day.